So before going to learn the actual algorithms, we should understand some prerequisite concepts. So the first one is nothing but linear algebra. Actually, we don't need any high level of mathematics, but we should know we should have the understanding of how the data are actually represented, how dot products work, what is the vector, what is matrices, those kind of things. So the first question is that may comes in your mind, then why maths in ML? Yes, actually, that every ML model, he represents data either as vectors or matrices. And the learning, in the learning, you will know learning is nothing but the adjusting the weights of the features. So what is weight? Weight is nothing but the importance of a particular feature. So that which particular feature will get most importance. Like if you're predicting the house price, there can have features like size of the house, and one feature is which gender used to stay there. So you can understand that which gender used to stay there is not that important. Even it is quite irrelevant. So we'll give it, make it weights minimum as possible. So we'll adjust the weights so that we can reach to one optimal solution. Optimal solution means we'll try to minimize the errors. Yes, we'll try to minimize the error. So only then we'll get one model that will do its task or operations near to perfectly. Yes, so that's why, and those things can be achieved via mathematics. That's why those are important. So the now question is, what is vector? In lower class, you have studied that vector is a quantity that has a magnitude and direction. It is correct in terms of physics, but in machine learning, vector is nothing but any point which can be plotted, which can be plotted on a graph. And vector is nothing but a list of numbers. So like if you have one particular variable, inside of it, it can contain several numbers, and the numbers are nothing but the data points. It can store the data points. And what is matrix? Matrix is a two-dimensional way to represent the numbers. Yes. So how a matrix should look like? Just understand that. Suppose if we have one data set like the student study data set, student suppose study hours, and suppose marks. So this is for the student 1 and this for student 2. Suppose he is studying for 2 hours daily and studying for 5 hours daily. So he is getting the marks like 50, he is getting marks 80. You can see it's like it's a matrix. That means it has some row and it has some column. So what the rows are actually indicating? Rows are saying that rows are taking one data sample. And then what about column? Columns are nothing but the each column, you can see each column is taking one feature. This is not our feature, this is our target variable. Those are the features, the study hours like. Yes. So it can be represented as So is x. This is my feature. I can represent it via x. Suppose this is y. So x is containing two values like 2 and 5. And what about y? Y is containing 50 and 80. That's how we represent the data. Yes. So now we have to understand one thing, that is nothing but your dot product. And it is important. The dot product will be used in several algorithms. Let's take one example. Suppose if we have two vectors like A and it has the values like 1 comma 2, and we have another vector like this is B and it contains values like 3 comma 4. So what will be the dot product of A comma A and B? It will be nothing but element wise multiplication. So element wise multiplication means first element will multiply with the first element of the second vector. So that's gonna be a 1 cross 3 plus similarly the second element will multiply with the second value of that second vector. So 2 comma 4. So the ultimate value will be 3 plus 8, nothing but 11. So this is how a dot product actually work. In algorithm, you can do the algorithm, multiplication different way also. Suppose if we have the weights, suppose those are the weights 1, 2, 3, 4 in this way. And if you have the feature values like, so take 5, 9, 8, 10. So you can do the multiplication by the transpose also. What is transpose? Transpose means W transpose. You can do the multiplication like W transpose of X. You'll get the same value. How? Let's see. So W transpose is nothing but you are making the row as column and column as row. So you are just rotating it. So it will be 1, 2, 3 and 4. And X will be same, that is nothing but 5, 9, 8 and 10. Now take the value and do the multiplication. So 1 will be multiplied with 5. So we can do the multiplication like 1 with 5. Take the value and put it over the second variable. So W transpose, take the entire matrix and try to calculate that. So 1 with 5 plus 2 with 9 plus 3 with 8 plus 4 with your 10. So what will be the value? That is 5 plus 18 plus 24 plus 40, and that is near 32, 32, 72 and 77. That's how you can do the dot product. Yes, I think this is clear. So once we are clear with the dot product, we can understand one new thing, that is partial derivative and gradient. So what is gradient? Gradient is nothing but vector of partial derivatives. It is the vector of partial derivatives. And gradients will be used in our optimization. We'll try to minimize it. We'll reach to the try to reach to the local minima point. So gradient is the nothing but vector partial derivatives. And understand why one question. Suppose if we have one function like f of x comma y, it can be represented. So suppose this is a function, yes, it can be represented via function of x comma y, and the function is like very simple function like x square plus y square. So if we take the partial derivative with respect to x, so what you will get? You will only do the derivation with respect to the value which is having that x variable. So that will be nothing but 2x, because we know that dx of x to the power of n is nothing but n into x to the power of n minus 1. So this is n here is 2. So 2 will come here and 2 minus 1 is nothing but this 2 minus 1, that will be 1, so 2x. So when we will do the partial derivative with respect to y, so what we will get? Similarly we will get 2y. So the gradient, we represent it by this symbol. So this gradient will be nothing but your df by dx partial derivative with respect to x and derivative with respect to y, and the values are 2x comma 2y. And when once you will see the gradient curve, it looks like something this, and this is the point, yes, where the gradient is negative, here the gradient is positive. How you can understand that? Just draw a line, draw a slope. If the face of the slope is clockwise, then the gradient will be positive. And if you draw a slope in this direction, you will see it should touch, and the face is in the anti-clockwise, so gradient is negative. And our aim is to reach to that lowest point. And at that point, our whatever the error our model will create will be minimum, and that is our desired point. So this is there is the gradient is maximum, and we move opposite to the opposite to gradient. That means we'll move in this direction, either this direction or this direction. Yes. So that much of mathematics like algebra is sufficient. This is part of the calculus also, and we'll understand a few more things like the convex analysis and optimization techniques in the next lecture. Practice those things. I'll provide some questions, practice those things, and I think that is more than sufficient. Even 10 12 11 12 level mathematics is more than sufficient to understand machine learning. So thank you for watching. We'll see you in the next lecture.